250 million people, streaming video, simultaneously. Zero buffering. How does Netflix actually pull this off? Let's break down the entire architecture. When you press play on Netflix, a surprisingly complex chain of events happens, and it involves two completely separate systems. Let's start from the beginning. Netflix has two main infrastructure components. First, the backend. This runs entirely on Amazon Web Services, AWS. It handles everything except the actual video. User accounts, recommendations, search, billing, the entire application logic. Thousands of microservices talking to each other. Second, Open Connect. This is Netflix's own custom CDN, content delivery network. It handles one thing, streaming the actual video to your device. Netflix built their own CDN because existing ones like Akamai weren't optimized for their specific use case, large video files at massive scale. Let's trace what happens when you press play. Step 1. Your Netflix app talks to the backend on AWS. It authenticates you, checks your subscription, and uses machine learning to decide which video quality and encoding format works best for your device and network speed. Step 2. The backend tells your device, go get the video from this specific Open Connect server. It picks the closest one, with the content already cached. Step 3. Your device connects directly to the Open Connect server, usually physically located inside your ISP's data center, and starts streaming. The backend is no longer involved in video delivery. This separation is genius. The backend handles complex logic on AWS. Video delivery happens from servers literally inside your internet provider. That's why you rarely buffer. Now let's talk about Open Connect in more detail. Netflix has over 17,000 servers deployed in more than 6,000 locations worldwide. These servers sit inside ISPs, internet exchange points, and local data centers. During off-peak hours, typically 3 a.m., Netflix pushes new content to these servers from their central storage. So when a new season of a show drops at midnight, it's already physically on a server 10 kilometers from your house. You're not streaming from the US. You're streaming from your neighborhood. Each Open Connect appliance, or OCA, stores the most popular content for that region. They use predictive caching, machine learning models that predict what people in each region will watch, and pre-position that content. Now, the microservices architecture. Netflix runs over 1,000 microservices on AWS. Each service handles one specific function. There's a service for user profiles, one for recommendations, one for playback decisions, one for billing, one for A/B testing. They're all independent. Why microservices? Because when the recommendation service has a bug, your video doesn't stop playing. Services fail independently. Netflix coined the term chaos engineering. They literally inject random failures into production, on purpose, to make sure the system survives. Their famous tool, Chaos Monkey, randomly kills servers during business hours. If your architecture can survive random server deaths, it can survive anything. Let's talk about data. Netflix generates massive amounts of data. Every pause, every rewind, every time you hover over a title, it's all tracked. This data feeds into their recommendation engine. They use Apache Kafka for real-time event streaming, processing millions of events per second, Cassandra for distributed storage, and a custom-built data pipeline that processes petabytes daily. The recommendation algorithm alone drives 80% of what people watch on Netflix. It's not just people who watched X also watched Y. It analyzes viewing patterns, time of day, device type, even how long you look at a thumbnail before clicking. What about reliability? Netflix operates across multiple AWS regions. If one entire region goes down, traffic automatically shifts to another. They call this active-active architecture. Both regions serve traffic simultaneously, so failover is instant. They also use circuit breakers. If a downstream service is failing, instead of cascading the failure, the circuit breaker opens, returns a degraded but functional response, and prevents system-wide collapse. Let's summarize the key architectural decisions. 1. Separate control plane from data plane. Backend logic on AWS. Video delivery on Open Connect. Different scaling needs, different solutions. 2. Put content physically close to users, not in a central data center, inside your ISP. 3. Microservices for resilience. One failure doesn't cascade. 4. Chaos engineering. Test failure in production before it tests you. 5. Data-driven everything. Recommendation, caching, encoding, all powered by machine learning. This architecture serves 250 million users, streams billions of hours monthly, across 190 countries, with 99.99% uptime. That's less than 53 minutes of downtime per year. Next video, how Uber matches 20 million rides per day in real time. Subscribe to Tech Growthspire.